All right, everybody, we're going to start our AI Summit. So I want to introduce Matt Enstis, the CEO of Buffalo Niagara Medical Campus. And thanks, Matt. We'll step up and give us a couple notes here.
Yeah.
Good evening, everyone. It's great to be here in the medical school. When we come by here, we saw this building being built, and we started to use it for so many different things. The most important thing to me is I'm going to start by thanking Sam and Xiaoming for pulling this together. We did this once before with Professor Bina and Sam looking at blockchain, and now these two great men bring together looking at artificial intelligence, but using a great way to bring academia and the private sector together to start talking and thinking about this. And as we built out the medical campus, that's what everybody intended to see happen. So when we start seeing events like this and that coming together, that's what's really exciting to us and for everybody that's here. You know, and we have our good friends from M&T Bank, from Moog, from Value Centric, from Trove, all the way to the smaller companies, the startups like Burner Fitness. And we're seeing this all start to come together. It's truly exciting to us. The biggest thing that I would like to see most, and I don't know if many people follow this, about a year ago, the Jacobs Institute, which is located here on the campus, looked at the future of medicine. And if you haven't seen it, I'd go to their website. And if you want a book, just reach out to someone on our team and we'll get you the actual book to read. But it really is looking at all the mega trends that are out there that's changing the dynamic in healthcare and medicine, but that goes across all industries. And so to see all this come together and to have these groups here really is watching the studies and the works that we're doing, but also the physical development that everybody's seeing here. And in our wildest dreams, we really didn't think it would happen as quickly as it started to happen. So have a great time at this event. Sam and Xiaoming, thanks for pulling this together. You did it in a relatively short time frame too. So thanks everybody for being engaged, thanks for being here, and thanks for being a partner.
Good evening. I'm Chip Zagoskin, the provost at the University of Buffalo, and I too am very pleased that we're holding the summit on AI and machine learning here this evening. I think the conversation we're going to have is going to be very stimulating. We're going to hear about the history of artificial intelligence at UB, but more importantly in all of Buffalo from Dr. Srihari, who has been part of this scene from the beginning of his career and has delivered 40 years of experience here at the University of Buffalo, taking us forward. UB has a lot of strength in the area of artificial intelligence. It will date back 40 years and we'll hear this history, but we can now see it in any number of places across the campus. Right now we have on the North Campus, Computer Science and Engineering has this bus Ollie that I got to ride around in today, and it's a fully autonomous bus that is driving around, and at the moment it stops a little rapidly. That means it probably won't run into you because it's simply so sensitive to bumps in the road. We also were building a drone facility. It's a cage for drones. It's the largest in the country, and it'll be built probably sometime next summer. You can come up and see swarms of drones communicating with one another and flying around, and we hope not crashing into one another too often, but the object is to keep them from doing that. At UB, we also are using artificial intelligence to teach better, faster. The Graduate School of Education and the law school are both developing artificial intelligence systems that also interface with virtual reality and create experiences for students, in the case of the Graduate School of Education, that they are able to learn how to teach, stand up in front of groups like you, and interact with them in a virtual reality artificial intelligence way. For the law school, they're doing the same thing for courtroom analysis. These are aspects of what we have going on right now, and going into the future, we have built it is the Institute for Artificial Intelligence, UBuffalo.ai, that will bring together all of those sort of all of those programs on sort of an actuality together, where there are sort of three key thrusts right now. One is autonomous vehicles, the second is digital imaging and relating it to healthcare, and the third area is sort of the fundamentals of artificial intelligence. And this program will address not only the technical details of directions that we're going and the new technologies and spin-outs that will come through that will drive our economy and drive Buffalo forward, but it'll also address the questions of what are the social, societal, and cultural implications of having these machines that can think differently and faster in many ways than we can. What are the moral and ethical implications of having your pet artificial intelligence over here that's supposed to augment your life, not take you into some dystopic world. And so bringing all of that requires bringing together all of the skills that we have at UB as a comprehensive research university. We're very excited to have David Doermann, who's sitting here in the front, who's going to be the director of ubuffalo.ai. So stay tuned. A lot of exciting things are going to come from this. Now it's my honor to introduce Dr. Srihari, who has been at UB for 40 years and helped build Caesar. Caesar? He says, whatever he says. This is a center that we've had for many years at UB that developed concepts around pattern recognition, where one of the first applications of artificial intelligence was actually begun here that Dr. Srihari helped develop, and that is the Postal Service's ability to read with something like 4 or 5 nines accuracy our handwriting and have the letters delivered to the right address when we write it down by hand. And that pattern recognition was developed here, the initiation of that was developed here in Buffalo at UB, and Dr. Srihari is now going to talk to us about where we are with artificial intelligence in Buffalo and at UB.
Thanks, Chip, for a lovely introduction. I have here Alina Bereshka. She's a graduate student working on reinforcement learning, a kind of very cool idea in machine learning today. So she'll be handling the audio visuals for me. Thanks, Bereshka. Thanks, Alina, I should say. Yeah. So when Chanming asked me to give this talk, I said, all right, let me talk broadly about AI. And I always keep telling my students over the years, over the last 40 years I've been teaching, that some of AI actually began in Buffalo. And in those days, it was early on, there weren't that many people interested in hearing about it. But today I think it's become very relevant. So I will talk about this. And when you see in the news media, they talk about AI as the new industrial revolution. It's going to change everything. The economy is going to be changing. Society is going to be changing. So that's how they talk about it. And of course, I said, okay, where is the story here about industrial revolution? Truly, Buffalo has had a connection to several industrial revolutions. So I will trace the story, how Buffalo had a role in the earlier industrial revolutions and how the current industrial revolutions began here in Buffalo. And what has been going on for the last 40, 50 years. And my own speculations about where we are going. And I'm, of course, part of this utopian side of things as opposed to the dystopian side of things. That is, this is all going to be good as opposed to it's all going to be bad. Right? Anyway, I'll trace that story. So what I'm going to do is I'll talk about humanity, human civilization over the years has encountered maybe 3 or 4 maybe, big technological revolutions that changed everything. Starting with the industrial revolution, going on to the electrical revolution, electricity came around. And then the computer revolution, when everybody, for everything, we started using computers. And now we are at the AI revolution, which got started quite some time ago, right here in Buffalo. We've been doing these kinds of things, but finally it is now coming out into the open now. So I'll trace that history a bit, which is a little bit of an unlikely story for everybody to hear about. Buffalo had a central role in all of these things. Yeah. Okay, let's move on. So the grand technological revolutions that humanity has dealt with, of course, you know, there was the first industrial revolution, started with the Arkwright water mill in England, and they were then converting various handcrafted things into machines run by steam engines and so on. And so that was in the 1770s. Maybe Buffalo didn't have much to do with that part of industrial revolution because it was just being formed over here in North America. But anyway, a lot of our earlier industries here were of that kind. But the real revolutions that Buffalo had a role in began with the electricity revolution, when electricity changed everything. That now we had power, we had light, we could drive motors, so many things we could do with electricity, refrigerators, you know, fans and heating and so on. You know what electricity is used for. Maybe garage door openers, what have you. Electricity drives everything. And Buffalo had a very central role in this thing because of Niagara Falls. There's been a lot of recent write-ups about this. Buffalo has been called the City of Light. This is the first city in the world to have had street lights powered by electricity. And there's a very interesting story about which is the first city in the world that got electricity. And there is some discussion about it. What happened was there was a war of currents, they called it. There was Thomas Alva Edison in New York, in the East Coast in New Jersey. He lit up Manhattan with direct current. And then they said, okay, we should be able to generate electricity from hydropower, and here was Niagara Falls, and they were going to generate power, and they were going to use that power to show what it could be done with it. And they said, okay, let's go light up the streets of Buffalo with it. So, but the engineer in charge of the motors and all here his name was Nikola Tesla. So Tesla and Thomas Edison were on opposite sides. Edison wanted DC and Tesla wanted AC. He said, you know, if you're going to use DC, you're going to have serious power losses. Electrical engineers call it an I squared R losses. Right, over that distance, there's a lot of resistance, so the power is going to dissipate. It's not going to work well, and he wanted to put AC in over here. Anyway, Tesla won out, and today the norm is AC rather than Thomas Edison's DC. And so anyway, Buffalo played a role in all of this in a very central way. And if you go to Niagara Falls, you would see a huge statue of Nikola Tesla over there. So it's the origin of electrification. So Buffalo has a role in that whole revolution, which is the electrical revolution. Moving on, say around 1970, this is all circa 1970, it would be 20 years earlier, roughly. So it was the revolution of computers. That computers were going to take over everything. Time magazine made a computer the man of the year, right? Some of you old enough may remember that. And so the computer revolution played a central role. And what I show here is an IBM 360 over here. We'll talk about it a little bit more. And of course, today we talk about the fourth revolution, which is artificial intelligence, which is about computers or machines performing as well or better than human beings at a lot of tasks. And I put a dystopian picture over there. It was IBM, I believe not IBM, it was the AlphaGo, Lee Sedol, the world champion on Go. It's kind of that picture that is falling down in front of the computer. All right. So let's talk a little bit about this AI. What is AI, first of all, before we going on to the AI revolution? AI is ubiquitous. We all have AI in our pockets or in our cars. So what are the kinds of tasks that require intelligence? This is the kind of thing that AI does. Reasoning, like games, that AlphaGo we just saw was an achievement of of the group now with Google. Planning, we all use maps and things like that, action sequences, and they're incredibly. They can tell you the shortest way to go from. Or if you're driving from here to New York City, it gives you different routes, or maybe to Washington DC. I've driven several times. It gives you different routes every time. It's figuring out the traffic and so on, reasons out. So AI at work here. Natural language. We can type in natural language sentences into the Google search engine box. It figures out what you want. Or you can speak into the Google search using various handheld devices. It figures it out. Sensors. The picture I put at left is the path for an autonomous vehicle. A car is driving without hitting the barriers on the side, and the road is turning. It's lowering the speed and turning the steering wheel and so on using sensors. Or we of course have things like the Alexa, where you can ask Alexa to wake you up, or call your wife or husband and so on. So AI is ubiquitous. It's already here doing intelligent things. So the argument here is that the AI revolution is already here, and one could argue in comparison to the industrial revolution, the AI revolution is larger. The AI revolution, of course, disrupted society. AI revolution is larger. Steam engine took over physical labor, but AI can perform both physical and intellectual labor. Not only all these kinds of things, such as finding a path or understanding language, but also possibly drive a car and so on. Faster. The AI revolution is faster. Industrial revolution took centuries. It might have started in England, but by the time and maybe America, by the time it went around the entire world, it took a few hundred years. But this AI revolution is instantaneous. Simultaneously, it is going into place all across the world. All right. So again, I think I went over this concept already. This is my slide about the role of Buffalo in the electric revolution. On the top right is the first generating plant, which was not the current plant that exists. It was the Shelkoff plant. You can still, I think, somewhere near the aquarium of Niagara Falls, around that area, there is a Shelkoff plant. That's what it looked like. They were generating power from there. And the bottom here, I found a picture of people rejoicing in Buffalo. That's a Buffalo picture with all the street lights, which came from Niagara Falls, from Shelkoff. And there is a statue of Nikola Tesla, who invented alternating current. Buffalo was the place where it first went into action. And visibly, there is a huge statue of him. All right, now what about the computer revolution? Did Buffalo have anything to do with it around the 1970s or 60s, where computers suddenly became commonplace all over, everybody beginning to use it? Interestingly, there's a nice connection to even the computer revolution, may not be as strong as the first electric revolution. Thomas J. Watson Jr., he's the one who founded IBM. And if you look up his biography, he actually spent several years here in Buffalo. He was a salesman here in Buffalo and was extremely good at it. And then he went on, he moved a little bit to the east and he moved there and he founded this company called IBM. And I just put up a few pictures of IBM's enormous importance in the computer revolution of 1970. All of these I put up there. In my own lifetime I've used these things. The first on the left hand is the IBM System 360. I came here as a graduate student in that year, 1972, to America. And I was a computer science major even at that time. So I used to write all my code and submit them as jobs on punch cards to the IBM 360. That's what it looked like. And then later on, about 10, 15 years later, we had the IBM PC with an IBM invention. And then much more recently, in the last decade, we've had a program called Watson, named after Thomas Watson. Beat Ken, the world champion Jeopardy player at that time. That was also an IBM device called Watson. And eventually they spun off an AI unit called Watson. And on the fourth picture I have next to Thomas J. Watson is a laptop which I think many people still use. It's called a ThinkPad. I believe it's still called a ThinkPad, right? And Watson came up with the name Think, the word Think. He used to tell everybody that was his key phrase, and so that word still lives beyond Thomas J. Watson Jr. Now, when I came to America as a graduate student, I had to do all my programs in punched cards. In the bottom, you can see over here punched card machine and a reading machine, and there was also a machine where you would sit in a key punch, and you would type in your code. Every line of your code would be a new card. So you would have a deck of cards, which would be a computer program, and you would put another card called a job control language card after that, followed by your data set, which is also punch cards, and you'd feed the whole thing. So when I came here as a graduate student, I would punch my cards on this punch card machine and submit it to an IBM 360, and after about 4 hours, they'd allow me to go and pick up my job. What it did, it would say, well, okay, you got a job control error, you got a bug here, whatever, do it all over again. It used to take, days to get a program right. Now, very interesting is the Buffalo connection here. The one who came up with this idea of punch cards and the punch card machine was a man called Herman Hollerith. And look him up, Herman Hollerith was born in Buffalo. So he was born in Buffalo and went on to Washington, D.C., where he set up his tabulating company and so on. So interesting connections, may not be as strong, but it's still some of the key players in the computer revolution came from here. All right, now I've already introduced to you what is this AI. A very strong connection to AI is what happened in Buffalo in the 1950s. A man called Frank Rosenblatt. A young man, he worked at Calspan Corporation. At that time it was known as Cornell Aeronautical Laboratories. And he worked there, and he had this, he was a cognitive type of scientist, and he wanted to actually build a machine that behaved like a brain. At that time, even in the 50s, earlier on, neuroscientists had figured out what a neuron in a brain is like. Like it would have, a neuron would have several connections, and when all the other connections fired, this neuron would fire, or it would not fire based on what came in. It was this idea, and he actually decided to build a hardware. And this piece of hardware, he called it as a perceptron. It was known as a perceiving and recognizing automaton. And the technical report dated 1950, done here. And very interesting connection here is that his work was funded by a person called Marshall Yovitz. He died earlier this year in his 90s. Marshall Yovitz was the chairman of the Ohio State Computer and Information Science Department. When I came there as a graduate student, 48 years ago. And Marshall Yovitz was his funder, and he encouraged AI research in those days of this kind. This kind of AI was not well looked upon. It's not like a quirky thing. You're trying to model the human neuron, and what would that going to be? Anyway, this is the connection. This is the kind of diagram he had. He had a diagram which says all the inputs come from some image here, and there would be a weights that we're going to be multiplying each of these things, and we add them up and threshold it. This is the kind of idea he had. And he had engineers wire the whole thing. There are all kinds of pictures available of people looking at the wiring diagrams, and people illuminating a printed character C over there to see whether the computer can recognize C from a B from an A and so on. And then the right picture is kind of a bit dark here. It's a man holding some resistors, rheostats and things like that. So this was all done in kind of analog hardware, and they built them here in Buffalo, and that was the perceptron. And they called it the Mark I perceptron, the first embodiment of their research. Today it sits in the Smithsonian in Washington, D.C. Perceptron still exists. And today we have what's called as deep learning, and we still refer to the deep learning as the multi-layer perceptron. So that idea which started over here, started here in Buffalo. So what happened was, this was done in a location in Buffalo by Rosenblatt and so on. It was not really accepted by the intellectual community in the power centers like MIT and Stanford and so on. Marvin Minsky, who is shown on the top left here, was the guru or leader of AI in the world, and he was considered the authority on it. He and his colleague Seymour Papert from MIT, they said, there was a lot of publicity for perceptrons. It was written up in the New York Times and so on, that a brain is being modeled 60 years ago. 60 years ago, New York Times, there is a major article saying about AI. And Minsky and Papert wrote a book saying, this thing cannot even compute simple things. It can do a few operations. It cannot compute what's called the exclusive OR operation. When two things it fires only when both inputs are different, but when they're the same, it doesn't fire. It's called the exclusive OR operation in binary mathematics. They showed it cannot be done. And they showed this cannot be done, that cannot be done. And this is a pretty useless type of idea. So, and they wrote a whole book called Perceptrons, MIT Press in 1969. And the book came out, very influential people wrote that book. By that time, Rosenblatt died. Rosenblatt died a young man at 41. And so he couldn't take his ideas further. And the idea of a neural network or a perceptron kind of died, saying the big AI people don't believe in it, let's not go any further. And Minsky was so influential, one of the earliest AI movies, it's called 2001 Space Odyssey. And this movie was done by Stanley Kubrick about what can AI achieve. The movie came out in, I believe, 1970, that year. And 2001 was 31 years away. So it seemed like a far, far time away. And what would AI be able to do in these 31 years? And that was kind of incorporated into 2001. There's a picture of the computer that's called the HAL computer, HAL. The letters are one removed from IBM. And HAL, they went, these were astronauts going on a mission to Jupiter. And the computer is an AI computer. And it at some point decides the human beings inside the craft cannot be trusted. They jeopardize the mission. So whatever they say, I'm not going to follow. So it became a computer that takes over, kind of stuff Elon Musk talks about today. But anyway, they kind of had all of these ideas. There was speech recognition. You could talk to HAL. That's the face of HAL there. And so anyway, he was very influential. So he was influential in perceptrons. All right, now, no harm. UB started a computer science department in 1967, 2 years before Minsky and Papert wrote the book Perceptrons. And we celebrated the 50th anniversary of our department last year. And right from the early days of the department, we've had a very strong AI component. People were very interested, faculty members were very interested in AI in the early days. It's that, I came here about 10 years after the department was founded, and my colleagues were some of these people. There was Nick Fiddler on the top right. He wrote a program for playing poker, computer poker. And it was quite an achievement. It was on the cover page of Scientific American. It was that important and interesting enough that Nick Fiddler's project in around 1978 was when it appeared. David Doermann was here. He was one of the pioneers of computed tomography. So when we go for a CAT scan or an MRI, what are the kinds of algorithms that analyze those images and produce those images? That was a computer vision type of problem. He was more of a mathematician, but one can regard that as an AI type of solution. It was done here in Buffalo. He had an amazing group here. Next is George Shapiro, and we have the privilege of having him here in the audience somewhere today. So he's over here. I was he was an inspirational figure as well. I met, he and I have different viewpoints on AI, but I keep telling him, we have respect for each other in different schools of AI. And when you go to a website called Google Scholar, the first thing they put, their tagline is on the shoulders of giants. All right, we have a giant, Stu Shapiro. His approach was knowledge representation and ideas like that. And of course, I put my picture because I also came at that time. We were all colleagues at that time. And then we have Bill Rappaport, who was a philosopher turned computer scientist. So we had all kinds of things going on. I think I've left out a few more. There were so many others who came and went. If I left out anyone current, my apologies. This is just a picture. Supposing we took a picture in 1978, 40 years ago. This is the AI that was going on in Buffalo. There was also Brian Funt and so on who came from Stanford. We had a few people. Yeah. All right, let's move on from 1978 to around 1983. That was 35 years ago. I was looking for funding. I was a young assistant professor here, and somebody told me that the U.S. Postal Service is trying to automate their reading machines. And I approached them saying, would you be willing to fund me to see whether computers can read handwritten postal addresses? They first laughed at me, saying, I can't read my own handwriting. Can you get a computer to do this? And so anyway, they gave me a small grant and so on. One thing led to the other. Eventually, we became the largest center for postal type of research here at UB. One time, we had 150 people in the group, all doing something related to postal work. The envelope you see here, you see the date on that on the top left is 1996. That was what, about 22 years ago. That was when the first postal handwritten address reading system went into operation. They installed it at the post office in Tampa, Florida. You see the cancellation on the top right, Tampa, Florida, October 1996. We were getting ready for Christmas season, 1996. So that's when the handwritten mail hits the post office. They need most labor to handle the mail. So we were testing it at that time, and I took one of the UV envelopes and I just wrote my own home address and had it posted from Tampa to my home. And lo and behold, it came home, and it had a barcode at the bottom, and the barcode is what's called as a delivery point code of the postal address. It's the zip plus 4 plus 2 code. It is a 5-digit zip code. My zip code is 14221. And then it adds on a 4-digit add-on, which is obtained from the street address here, and the block face actually, side of the street I live on. As a 4-digit, and then 2 more digits correspond to the last 2 digits of the street number. That's the 11-digit barcode. Correctly did the whole thing. And so this took us, that was 1996. My funding for the Postal Service started in 1983. So that was another, it took us 13 years to get this done from scratch when we started looking at what does it take to recognize handwriting. And this led to a lot of interest all over the world about what is this problem that there's so much work is going on. And so people today, even today, say recognizing handwritten digits by computer is the fruit fly of AI. So if you have a new idea in AI, can you recognize handwritten digits? You start there and then you go on to more complicated things. So it's the simplest organism you can think of as a test for AI. And to this day, when some of the greats in AI come out and say, I have a new idea, this is how it's got to be done. Well, okay, let's try it out first on handwritten digits. There's what's called as the MNIST handwritten digits are used the world over as the standard today. And kind of, it all started when we were doing postal address reading here at UB. And then that one thing led to the other, and the Department of Justice, right? So much in the news. Department of Justice approached me and said, you guys are known for, we got a lot of press on this, New York Times, everybody is writing about handwriting reading machines. And so we were asked, well, would you be able to help us? The Department of Justice is facing a crisis that they cannot admit handwriting evidence in the courts in criminal cases because of a famous ruling called as Daubert versus Merildow Pharmaceuticals, which said unless there is a scientific justification for the expertise, it cannot be admitted as evidence in the court in front of a jury who don't know better. So the judge has to decide whether this evidence is going to be admitted. Handwriting was going to be out because there was no science to show that handwriting recognition could be done in the sense, who's the writer? Is it possible at all? So we got the very first project in the world here comparing handwriting to see, can we use our algorithms done for postal machines? Can we go about looking at handwriting, not for recognizing things, but to say whether two things were written by the same person or not. And so we were able to write some influential papers on this topic. It can indeed be done, that it is indeed possible to discriminate between people's handwriting if we have training samples from them. And that allowed handwriting testimony to be continued to be presented in the courts. And to this day, it can be. It actually went up to several federal court cases. So today there is what's called as a Daubert hearing before a case is done. saying if there's going to be any kind of expertise, does it satisfy the criteria? And we played a role in allowing handwriting testimony to be presented, which came out of this AI work. This postal project was so large that we had nearly 150 people participating. We had dozens of PhD students, many master's students, and so on participating in so many projects. Many careers were made out of the work of the postal project. I just highlighted one of them here. Today, one of the best algorithms for doing pattern recognition or classification. Given something, can you say it is this or that? One of the top algorithms for it is called random forest. And the random forest algorithm was invented by my PhD student, Jin Can Ho, and she is today a lead scientist at Watson, which is the IBM spin-off in Manhattan. Okay, so those are some of the connections. All right, okay. Here is a little bit more connections, which are kind of people. My talk is a little bit about people. Who are the people who did all of this? So today, if you go and look around, deep learning, that's what the main technology that drives AI today. And if you go and look at who are the greats, these are considered to be the great people, and they are indeed. Interestingly, I just have a connection to these people in the following way. On the left is Yann LeCun, who is a professor at NYU, and he directs AI research at Facebook today. And next to him is a legend called Geoffrey Hinton. He's an English. Yann LeCun is a French origin, lives in New York. Jeffrey Hinton is an Englishman, and he used to be at CMU, but he decided he liked Toronto better. He's a professor at the University of Toronto, and he again is a lead at Google today. And the third one is Yoshia Bengio, who is actually a student of Geoffrey Hinton in Montreal. Canada is a hotbed for AI research today. And the last of these is Andrew Ng. And almost everybody who's gone to look for Coursera on machine learning and so on encounters Andrew Ng. He's very famous, and he used to be a professor at Stanford, and then he left Stanford because again another company, Baidu, which is the equivalent of Google in China, decided, why do you want to work for Stanford, come and work for us, and he moved. And what's the connection of these guys to UP or Buffalo? Very interesting that when we had a huge postal project, the US Postal Service said, there are some smart people at Bell Labs, so why don't you give them a subcontract from UP so they can help you with some of the recognition tasks that you're doing. And so we were asked to give a subcontract to Bell Labs, and the subcontractor at Bell Labs in Mumbai was Yann LeCun. So anyway, those were the early days. We were all young at that time. I'm talking about 25 years ago. And Yann LeCun's connection to UB is that. Geoffrey Hinton, he's an unbelievable legend. If he was in any other field, he should have got the Nobel Prize. There's no Nobel Prize for computer science. Geoffrey Hinton, he was at Toronto, and we were all young people 25 years ago. He called me from Toronto, UB, in Buffalo, and said, yeah, I know you guys are doing handwriting recognition. Can me and my students come and see what you're doing? I said, sure, come on over. So he brought all of his students from Toronto to Buffalo to see what kind of algorithms we were using to recognize languages, exchange ideas, and so on. So those are the early days, and that's my connection to Geoffrey Hinton. Yoshua Bengio is actually a PhD student, Geoffrey Hinton. So he's my buddy's student, so I have a connection to him. What's my connection to Andrew Ng? It's an interesting one. One of our master's students at UB is another legendary figure today. His name is Robin Lee. He finished at UB and eventually went back to China, and he founded this company called Baidu, which is the equivalent of Google. And you see a Baidu search engine box over there some years ago. And he founded that company, and it was as successful as Google in this country. He became the richest man in China. He was a billionaire. And I thought he would have forgotten me, as our interaction was a short period of time. And I sent him a message on the day his company went IPO, and he responded back saying it all started in your lab. So it made my day or whatever life that somebody did something worthwhile with what I had to tell them about. And so my connection to Andrew Ng, the famous Andrew Ng, is that my student had him work for his company. Right? Leave his job from Stanford to work for his company. So what are the connections here? All right. So let's go on. AI is not a solved problem. There's all kinds of problems that have been solved. AlphaGo has been solved. Search and so on a little bit has been solved. Very interesting AI paradox is what are hard problems for people? As people playing Go or playing chess, all kinds of things are hard for us. But such tasks are easy for the computer. The AI algorithms can do that well. They can sort through a lot of data and figure out what are the paths and so on. On the other hand, the easy problems for us, we can recognize our friends, we can go find our way to a chair in the auditorium, we can do all kinds of simple things. To get a computer to do that or an AI to do that is extremely hard. So today we are trying to solve this problem of general intelligence rather than narrow intelligence. Now what does it take to solve problems of general intelligence? So everyday type of thing that we do, which are hard for computers. So everyday life needs knowledge. So knowledge is intuitive and subjective. So the key challenge of AI is how to get this informal knowledge to the knowledge methods. So knowledge-based approach. So ideas for hard-code knowledge in a formal language. A computer can reason about statements in these languages using inference rules. So this is logic-based. We think of computers, okay, you must be doing logical stuff. Right, so that's the idea, to do things logically, to construct the axioms and the rules and so on. So this is the kind of approach called the knowledge-based approach. So this led to AI. This is after perceptrons vanished thanks to Minsky and Papert, and later on it all became knowledge-based AI, knowledge-based AI. So we've all been hearing about AI. It was that kind of AI, knowledge-based AI, where inputs go to hand-designed programs based on knowledge-based reasoning, and there was output. Disadvantage of this was it was an unwieldy process. It required time of human experts. Who's to put the knowledge in? We got to have people tell them what the rules are. And people struggle to formalize rules with enough complexity to describe the word. How do you recognize your friend? And what are the rules that you use for that? So asking people to think about what rules they do so we can code it in some kind of rule-based expert system was an impractical idea. It worked for things that you could spend a lot of time doing it, but not easily generalized. So this led to the machine learning approach. So the difficulties of hard-coded approach, so just allow computations to use, you'd figure out some representations. So the early approach was, we'll give you the representation and we'll map the features to outputs. So we use what are called pattern recognition algorithm. One simple example was to decide whether the email coming into you is spam or not. So that was a simple machine learning algorithm, and it shows feature spaces where you're drawing lines between the red crosses and the blue circles. Interestingly, red and blue are used in pattern recognition a lot, long before today's politics. So we have different algorithms that draw these lines in different ways. Some of them do better than the other, but the features were again given important. And there were more complicated ones. This is an algorithm that draws a nonlinear boundary, and so you could get more complicated machine learning algorithms. But all of these machine learning approaches still needed some features to be input, but you are not using decision rules at the top level, but not logic-based things, but doing a pattern recognition, we call it. Yeah. So there are two paradigms of AI. Rule-based system, which is input to hand-designed program to output, and the classic machine learning is input to hand-designed features to mapping from features using pattern recognition to the output. And only this box here that uses machine learning was mapping from features. So I got a bunch of values and given these values. Like with spam, we would say, does it have certain words? If an email, the first word of email is hello, it's most likely spam. Right? So you say, all right, that's probably the spam. So you would have features like that, which would tell you whether it's spam or not. So then came this deep learning revolution. Simple machine learning depends on what's called as feature engineering. You still have to figure out. Somebody had to tell you that hello is an indicator of spam. So that's called feature engineering. Or you would write a code. Say, okay, recognize whether this object is a car. You would say, well, okay, let me write a program to see whether this thing has wheels on it, circles on it, and That's called feature engineering. With a lot of difficulty, you would write such code. But it turns out for detecting a car, detecting wheels is not always a solution. Here are some peculiar cars which the wheel is not visible or only half visible or completely invisible because it is obscured and so on. So we got all of these scenarios where feature engineering, spending a lot of time writing code to figure out whether it has a wheel or not and then send it to an upper level decision maker, again was not feasible. So this is when deep learning came around. Deep learning is about saying we don't want to encode the rules, we don't want to feature engineer, we should just give the system raw data and it should work from that to make its decision. And that's what learning representations of data came along. So essentially these methods understand the world as a hierarchy of concepts. In image you get edges from the image, from the edges you get regions from the image, regions you get objects from the image, the objects together define the final, for example, the human face. So you would have edges and groupings and so on, several levels. And that's the idea here, a hierarchy of concepts. Concepts built on top of each other is deep, several layers like that. And this shows somewhat of the architecture here. We are going from an image to a final level, where on the way you are going through convolution, pooling, and all kinds of operations to make the final decision. And there are weights along the way to figure out what feature is important, what feature is not important. And that whole thing is done by the picture on the right side, which is the central mathematical concept in this style of machine learning, which is called deep learning, which is called gradient descent, stochastic gradient descent, the central algorithm. It is based on calculus. And today the coding languages for these things are called TensorFlow. TensorFlow is a flow of tensors, which are generalization of the scalars, vectors, matrices. Next thing is tensors, to be able to pass along derivatives, multiply derivatives with weights and so on. This kind of mathematics goes on. And these are layer derivatives. This is basically the idea that Rosenblatt of Buffalo was trying to do. He just had one layer in those days. He didn't have like many layers. He just had one layer. With one layer, you could do only some simple computations. If only he had another layer. Actually, mathematical result says you only have one more layer, you can compute a decimal exam. But it might be impractical because that one layer might be too big. The depth in deep learning allows you to compute all kinds of complicated functions. So basically, machine learning is simply a method to compute what we call as a function. A function, all it does is takes an input, maps it to an output. And that's what it does. And if your output is, well, I need to recognize a cat or a face or a dog or what have you. And that is all done by deep learning. So now we have three paradigms in AI. Rule-based system was the old one from the 50s or 60s, maybe 70s. And then the classic machine learning method, maybe from the 80s. And then on to today, which is deep learning. There are more gray boxes here. Simple features, additional layers, compute abstract features, and then mapping from the features is also done. So these are the three models. And where we are today is deep learning, this model. Actually, is this the final solution? Jeffrey Hinton just gave some interview saying, we should start all over again. He's saying, we need one more. So this might not be the ultimate solution, but that's where we are today. Okay. So let's go on now to the broad picture. I don't have all evening to talk to you about it. So let me talk about disruption in software development. So AI is not just another tool in the toolbox. Okay, this is the deep learning box. We're just going to use it. It could be fairly profound that AI, and people today are saying AI is poised to disrupt the world. Talking about an AI industrial revolution. But my perspective, of course, is not the whole world, but as a teacher of computer science. And I find a disruption in computer science itself. AI is disrupting my field itself. Some new terminology has come around. Today, the big AI players are these big companies. I already mentioned a few of them in Silicon Valley. One more of them is Tesla, this company that makes cars. And they have another genius.
Can you bend and go?
These are all
bend.
all these product engineers. probably in the 20s, maybe early 30s at most. They're all coming up with new ideas. And this guy called Karpati, he's got this theory which I tend to agree with, which the classical software development is going to change. He says the classical stack, we call it in coding, he said the classical stack in coding is, he calls it a software 1.0. It is code we write. We have a stack, it's called, you use a Linux operating system, Apache, MySQL database, Python, Perl, etc. It's called a stack. Make some of these choices, which is stack. And that is software 1.0. It is today's software development. Well, the view here is software 1.0 is going to get changed by software 2.0. It's a new style all based on machine learning. And the coding here is not in a user-friendly language like Java or C++. The coding is in a specifically user-unfriendly language. And because this is a language that looks like that, you see the box on the right-hand side here, it's got a whole bunch of numbers in it, real numbers. 3.606 is the weight over here, 3.603, and so on. So these weights are all figured out by the neural networks, Rosenblatt's multi-layer perceptrons. They compute these kinds of numbers. There are millions of these numbers which are computing what's going on. And there is no human involved at all in the coding. You are simply presenting it to it examples of what these are. And machine learning figures out what should be the weights to produce the kind of output you want. So there is no explicit coding, it's all based on samples and data. Continuing this thought a little bit more, we can talk about if you have a program space like this, shown in this diagram at the bottom here. By writing each line of code, the programmer identifies a point in program space with some desirable behavior. If it's the word of one program, you're saying that is the program I want, that's the program, and we kind of go about coding that program. This machine learning approach says, no, we are restricting ourselves to something here, in the blue region here, and restricting search space to continuous subsets of program space. And we use this idea called stochastic gradient descent. We zigzag through that to find the right point. So that's the kind of approach which is different from the current method of coding. So these are all kinds of benefits of this software 2.0. It's computationally homogeneous. The operations are only matrix multiplication in what's called as a rectilinear or rectified linear unit. Simple to bake into silicon. This kind of a program that's going to be based on machine learning is easily made into hardware. Constant runtime. Every iteration of forward pass the same number of floating point numbers. Constant memory. Highly portable sequence of matrix multiplication. It's just sequence of matrix multiplication. Everything is being reduced to that. And very agile. C++ is hard to speed up. Instead, remove half of the channels. Can meld into optimal code. You've got all these pieces of code that you've got. Everything is melded into one whole and you're bringing the whole thing together. Right? Finally, it is better than you. And anybody who write the code. And another thing about how deep learning is disrupting, my field of computer science itself is software developers in the past write and maintain layers of tangled code. All kinds of code, legacy code, people writing this and that and so on. And the future now is going to be, we are not going to be writing code, we are just going to be curating the data. So how to get the data in the right order. So we become data curators and we analyze the results. And the kind of mathematics that we need in computer science is also making a dramatic change. We've always been saying for the last 50 years, in computer science you only need discrete mathematics, right? Logic. So we are saying this new stuff is not based on logic, logical mathematics or logic in discrete math, but it's based on probability, it's based on calculus, because we're computing derivatives and linear algebra, about tensors and so on. So this is the kind of mathematics. The programming environments instead of C++ and Java, it's a TensorFlow, PyTorch, Gluon, and most software jobs won't need programming. And the diagram on the right says all these IT companies have developed their own environments for machine learning. Facebook developed PyTorch, and Google developed TensorFlow, Microsoft together with Amazon, both the C&A companies, They have a framework called Gluon. These frameworks allow you to code in this kind of new machine learning language, and it also it simply converts the code into parallelizing them and into things like hardware called GPUs instead of CPUs, GPUs or general processing or graphic processing. People have been somewhat skeptical. Is this in this far out? But the lead at Google, who's the head of their entire software division, young man, he said, I was very skeptical about this idea that all of software is going to get replaced. Then he went and looked at his own project. He's responsible for 4 projects at Google. This is upgrading search ranking. Of course, they bread and butter is search. And then data center energy usage is another project of this. And then language translation. You see that on Facebook and all, translate from German to English and so on. And then of course solving Go, they are the ones who came up with AlphaGo. We looked at all these projects and there are a lot of conventional code in it. He said, yeah. So he said at Alphabet, that is his company. And he said, yeah, all of this could be replaced by machine learning. I'm becoming a follower of this idea. This is a new thought, this idea of software 1.0, 2.0, and not been around for very long. But this came about by Karpati, who was involved in Tesla doing these cars. He said there were 2 types of coding in order to put into these Tesla cars. He said there's one type of code written by humans, then another type of code which is decipherable done by machine learning. And so right now maybe it's all equal, but I can see this becoming bigger and bigger machine learning. So these are people right there making these observations. And there are other things, repositories today. GitHub is the home for software 1.0 code. When you write new code in the lab, you share it with others by putting it out there. Say software 2.0 repositories are mainly data sets. You are trained on this data set. And commits is about making changes and so on, are additions and edits of the labels. Alright, let me talk a little bit about the future of AI. The utopian view is that boring and back office jobs will be eliminated. So whatever things are done in the back office, like whatever accounting and you can think of so many mundane jobs. People do that only because they need to make a living. So many of those kinds of mundane jobs are going to be eliminated. While human-facing jobs will remain. CEOs are important, right? There's money and all that. So CEOs are not going to be eliminated. But nurses will not be eliminated, facing job, or home caregivers and so on. Anything involving humans or maybe animals too, right? A dog therapist would probably, that job would be there and so on. And intellectually challenging tasks will be solved, like diagnosing disease. Of course, we talk about driving cars and customer support and so on. These are all going to be many of these kinds of things will be solved. Dystopian view says the negative view of wow, this AI, it's going to cause chaos. So, well, what's going to be the chaos? They took a survey, and this is just a speculative survey. This is the top AI conference today is called Neural Information Processing Systems. It's a conference that was, it's again based on neural networks. Neural. It was inspired by Rosenblatt. It was inspired by Jeffrey Hinton. These people started a small little thing. Let's just have a conference. Those of us who were doing this brain kind of thing. It was mostly Jeffrey Hinton and so on. And that conference has mushroomed. Today, that conference finds it hard to find a location. The last one, I think, had a registration of 8,000 people wanting to go there. And, Mark Zuckerberg apparently went to the last one with bodyguards around him and so on. So, but anyway, that's the kind of conference. And then there is also another one called ICML, International Conference on Machine Learning. These are all the number of people who would like to go there are of thousands. What they do is 6 months ahead of time, they close the registration, saying we cannot take more than 8,000, 10,000. We have to have a convention center, I think, to hold some of these events now. So, and so they ask these people who come to these conferences, particularly the ones who had papers, etc. So these are people who know what's going on. They ask them when can computers be learning languages, or driving trucks, or working retail, or working surgeon, or outperform all, and automating all human jobs. When is this going to happen? So anyway, this is a little bit fun type of thing, but it's a little bit scary. But this is the kind of thing that came out. But I've seen other reports here, like this was the British magazine, The Economist, saying that over 40% of the jobs at risk in the next 20 years in the United States. That's the Economist prediction. And they said the effect is going to be more, not in the rich countries like the United States, but on the middle-income countries. The middle-income countries will lose 210 million jobs. Again, this is all speculation, and this is what I am kind of seeing out there, and this is the kind of prediction. So AI, being poised to disrupt the world, has now had major impact around countries. There are national initiatives all over the world. Just in the last 2 years, Canada has been a leader. In 2017, they began in Canada with AI strategies. What the country is going to do about AI, which is going to hit us in society. And there are also opportunities as well in terms of developing AI. And I was in India over the summer, and India started its own program for the National Strategy for AI. And I got a copy of the report around July, August of this year. And I opened the report, and the first line of the report said, "Artificial intelligence is poised to disrupt the world." That's the first line of the India report. You might have got it from other places, but anyway, that's what they're saying. India is their planning agency. So let me go on to conclude here. AI at UB today. It is disrupting our enrollment in our own computer science department. This semester, I'm offering a course called Introduction to Artificial Intelligence. Early days when I taught, Introduction to Machine Learning, that's what it's called, Introduction to Machine Learning. When I taught a version of this course when I first came to UB 40 years ago, I tried to get some students into my class, and I couldn't even fill a class with 10 students. There are not that many people in this class. So today, guess how many students are there in one class? We have 350 students. 350 students in one class. There was no classroom big enough to hold 350 students. So we decided to break it up into two sections. These are the two sections that took the speeches last week. One of them in Knox Hall and the other in Hochstetter Hall. One class enrollment is 170 or something, maybe all the students are not there. The other class is the rest, is 190 or so. And then there's a deep learning class that I teach with 60 students. And there are a ton of other which have similar types of growth. Okay, my conclusion is that the AI revolution is comparable in magnitude to the industrial revolution, and some speculation is from more. And Buffalo has had a historical role in the past and present in technological revolution. And AI is poised to disrupt the world, and AI is already disrupting computer science. And AI will eliminate boring, repetitive jobs and create productive jobs, but there are opportunities and challenges in AI research. Sorry, I couldn't go.
So any questions at all from the audience?
Would you know of any companies that are, I don't know, you may have mentioned it, but would you know of any companies that are making some of the most advancements in AI technology right now?
So I think your question is which companies are making their biggest advances in AI today? In some of these companies we are also familiar with, right? The AI leadership is coming from Facebook, Google. Unfortunately, it's becoming a monopoly. Google doing everything. Google, Facebook, Microsoft, Amazon, and Tesla. These seem to be the leading companies. Of course, there are like hundreds of smaller companies all over, maybe thousands of smaller companies. Everybody is doing something in AI. But the big leaders who are kind of driving what we should be doing and who also have the data. They say today that data is the new oil, right, or new gold, right? Data is the new gold. So they are the ones with all the gold. These companies, they have lots of data on everybody, which they can use to construct better AI. That's what is needed for machine learning. So companies which have data are the winners. Yeah. But in the future, healthcare, like hospitals have a lot of data, and so they're also sitting on a gold mine over there, and they could also be using all of this data to. Actually, in India, they have a program there to have a different model. They're trying to say, why shouldn't people also profit from the data? It is my data you have. Yes, when that data is used, I should get back a little bit of that money for that. So there is a producer of data, a hospital, and there is a consumer of data, which is a company that's going to build something using your data. When that happens, the ordinary people in the middle will benefit from it. So there is a new place happening. I don't know if it's going to happen in America, but there is a way that people could benefit. If they give their data, it should be paid for.
We have a question here.
Srihari, how would a deep learning program listen to your lecture and ask an intelligent question based on the material you presented?
Stu, the kind of question I would ask would be easy for AI, but not the kind of question you ask, Stu. Stu has a brilliant mind, so. Alright, so yeah, I don't know. You played with Alexa and so on, they're doing it pretty well, they understand what you're saying. So how would it do? It would have to have speech recognition capability, and then it would have to go through of course, it would have to learn these things. Stu's point is that somebody would have to put knowledge into that program that it would have to use. Well, my point is that it's not that somebody wrote that most of the knowledge of presentation, but the knowledge has been learned by that program with experiences of various kinds of listening to people, generating questions. So it's a different model than the one where in this case, it's all a bunch of numbers. The representation of that knowledge is in the form of millions or billions or trillions of numbers. That's where knowledge gets represented. Not in a way that's understandable to you and me, but that's how it's going to be.
Given the time constraints, we'll have to move on. There's a roundtable going on, and the good news is that Harry will be here, and the beer will be served until 8 p.m. So we have time, to networking and ask additional questions. So I would like to thank our keynote speaker Harry again. And while we're setting up the panel, can we have the distinguished panelists to come, please? I wanted to just say a few words. Harry mentioned that Computer Science Engineering Department at UB celebrated our 50th anniversary last year. In fact, the reason we have this event today is to commemorate the first anniversary of October being proclaimed by Mayor Brown as the month of computer science and engineering in city of Buffalo. I don't know how many of you mentioned, and as our provost also mentioned, UB is doing a lot of things in AI. We have the new AI Institute. We're doing a lot of things, autonomous vehicle and drones. I just want to let everybody know that later this month, last week of October, we are going to have a UB Robotics Day. One of our faculty, Karthik, would you stand up over there? And we are going to showcase our autonomous vehicles and drones. So please, come to UB campus. There will be more announcement later on. Thank you. So I will hand the mic over to Sam, who's going to moderate the roundtable session.
Thank you, Chong-Ming. Thank you very much. You guys would love to have a seat for us, and want to let you know that with AI, at least, I'm not sure if it's going to replace my plumber, but for sure, it's going to replace my customer service. So I'll tell my kids not to become
can you handle this for a while?
customer service folks or dogs to become plumbers.
Yeah.
I think that would be a great way to get around that problem. So I want to thank everyone again at this. I know we're running a little late, but again, our distinguished guests.
Tripod is not getting proper.
To basically talk about.
That's what this pointer I made.
your DNA and start deconstructing your genomes and saying, okay, there's a mutation here, and we know Bob is, based on all the IoT that he has, we know he eats this type of food 5 days a week. It's probably not the healthiest thing for him. We know he's subject to these, let's say, climate conditions, and it has an impact on my health. And through machine learning, we'll be able to predict in 5 years, based on Bob's genetics, he's half Sicilian, half Neapolitan from Italy, and that population, based on all the data we've taken in, tends to move towards a particular disease based on all that data that we know. So it's going to get very prescriptive. And I was even reading there's smart pills you can take now that will take into your system, and it will start recording data from inside your body. That's fantastic. It's a little scary, but think of what we can do with that data. So there's a lot on the forefront, and we're excited about it.
Thank you. So just to add a little bit on to what Professor Srihari said about the disruption, it's not just in the classroom, a lot more students taking these courses, but it's also online courses that are available, the virtual environments that you heard about, augmented environments where different students can have different learning experience. But more specifically, our administration set up the University of Buffalo AI Institute to address really 3 problems. First of all is the research and all of the different things that are going on within the academic community. It's not just computer science anymore, it's not just engineering, but it's humanities, it's health, it's medicine, all of these different areas. So bringing those together, all of the solutions that we need to have for a lot of this research is interdisciplinary. You need people, bring people together to work on these problems. So that's sort of one thrust of the institute. Second thing is we have a lot of these people in different non-STEM areas that are going to be getting these tools and using them, and really understanding what the challenges of using this technology is. I mean, this is like a new hammer. You got to know not to hit your thumb with it. There's bias that creeps into the data. There are issues with security and privacy, and really, as you hear from both of my colleagues here on the panelists, industry wants this type of thing, and the UB, we're producing students that are going to go out and work for these companies, and they need to know how to be able to use these tools in effective ways and not cause problems that are going to be detrimental to these companies. And at the same time, companies themselves, you saw some of the ideas of what disruption is going to happen within the university environment, but also within other industries. If Amazon puts out these 3,000 Go stores that they are planning by 2020, that's a lot of cashiers. That's a lot of people that are going to be out of work. So it's not really a problem of complete disruption, but we need to transition. We need to be able to support the students. We need to be able to know what type of things need to be taught to our students across the campus. So the educational part is a really important piece. And it's not just a buzzword to the campus. They're really understanding what the needs are of companies and students that we're producing.
I like the new hammer. That's, when I talk about it internally at Moog, it is described that way. This is a tool, and it feels like there's at least enough of a chance that the presentation that we saw was a great, I love the Rosenblatt story. It was a great teaching piece. I really liked the presentation. We look at it, there's at least enough chance that this will have a significant impact to us, that we need to understand, what does this new tool do? What does it look like? What can it do? What are its limitations? What is it very good at? What is it not good at? And so really for us, internally, it really comes down to 2 different ways that we look at it. It looks like it has the potential to create new growth opportunities for us if we can figure it out, if we can harness it. I mentioned we're an automation company at our heart. We do the same basic thing, precision motion control in all these different environments, from medical applications to flight controls for aircraft to auto landing, satellite, in deep space, all these different applications. This looks like a tool that might be fairly universal. And then there might be new growth opportunities. As basically we're looking at adding intelligence to machines. And we look at it, our base business is basically making lumpy metal bits and then doing electronic controls and software to wrap control loops around it to do that precision motion control work. And now you look at adding intelligence to that or continuing up the curve of intelligence, and it's like this is going to be something that looks like it's going to be extremely useful, that it's going to find new opportunities for us. When we look at self-driving cars, automotive is one area that we're not in, but we look at all the opportunity that's coming out of that, all the technology spin-offs, all the investment that's going into that. We think, where else in the world can you apply that? And it feels pretty universal. And so really what we've been doing is pushing ourselves to actually get into actually employing the technology. We were counting the circles of the tools that were described. George sitting next to me is one of our engineers that's also has an unusual love of statistics and is a natural for embracing the new wave of machine learning and artificial intelligence. And so we've touched so far 6 of the 10 that you have in your circles. We feel like we just got to get a basic understanding of how it might be used, and both for new growth, but also then for how do we use it internally to improve efficiencies. There's already, everything has 2 views of it, the external looking, outward looking view, and the inward looking view. And so we've got at this point a number of proof of concepts that we've been working through both internally and with others. It's the one thing that, I don't know if it was, the presentation felt like the time periods were getting compressed as the years went on. And that's what it feels like at work. It feels like the world is going faster and faster, and it almost feels like there's no way we'll figure this out on our own internally, that we've got to partner with others. We've got to find institutions to work with, people in other fields that we normally wouldn't even work with. Enterprise software companies, like the Googles and Microsofts are now partners, things that we wouldn't have done 5 years ago even. And so there's both the internal and the external looking kind of version of it as opportunities. So it's really push yourself into it to learn, because you don't know what you don't know. And so, but what it does really feel like, it's a foundational technology, it's a foundational capability. It's going to have profound impacts. And so right now, we don't know what those are, and I think at least we're recognizing we don't know that. So we've really got to set ourselves up to learn. It's really pushing ourselves internally. It's not a natural fit into our businesses. When you ask, well, what are you selling? It's hard to come up with an answer to that. It's almost like, I don't know yet. I just have to figure out in the end, where is it going to take us? And then the last story I want to tell is, as we're driving into these new use cases externally, we start getting ourselves into thinking we're going to solve an automation problem out in the field. We're going to help in an agriculture environment. We're going to automate a piece of equipment. And so we do this demonstration with a bunch of commercial growers that do large-scale industrial farming. And the first thing they ask us is, can you give us a camera that points down so I can see as you're, it's great, you're taking the operator out of it, it looks like it might save me labor costs, but right now, can you give me a camera that points down and a camera that points sideways? I want to see what weeds you're going over so I know what to spray. And I want to see where the mold is occurring on the tree base before it gets away from us when I really have to spend a lot of money. And so that was kind of a lesson for us. These machines are all connected. It's like, oh, IoT, machine learning, big data, that's what it looks like for us, how to make it real. So really, that's kind of the story, is like, we've got to get out and figure out how to make it real for ourselves, for our leadership teams, for our business leaders. How do you turn it into, go from a technology into, it's got to be a business. This is what makes it all go. But have a future where is it taking?
Great responses from our panelists. I'm gonna skip to the last question, because these are some great answers. So I'm gonna ask you a question about what is it going to feel like when technology is making decisions you used to make, and can you provide an example of how AI will be making those decisions in the future in your organization? And basically, if you can answer this, this is a long question, but Bob's gonna kill me here. But what are your options or concerns on job losses and public acceptance of AI? So that's basically going to be, a lot of pressure we're going to see from, where I think these are shifts in new jobs. There's going to be many titles for new jobs that we don't even know of right now. There might be the chief AI officer. We're not sure what that is, what it's going to look like in 5 years, but let's hear your thoughts about that.
So I'll tackle last question first. So it's not the first time that we've seen technology come to the forefront and have people's jobs change. I mean, it started, back in the mills, where we started bringing, whether we're talking automotive, we brought the assembly line, and not all the auto workers went away. They learned new jobs, and we've seen that time and time again. I remember earlier in my career when I brought imaging systems into a health insurance company, and I was probably the most hated person because the thought was all the claimed data entry clerks were going to lose their jobs. They didn't, not one of them. They moved on to different, more skilled jobs, and in the long run, they ended up getting pay raises. So it worked out well for them. They eventually liked me again, but I think we'll see it time and time again. Today we're seeing it with DevOps is a big buzzword for most of us, and it's about automating releases, quality, but we're seeing people move from where they were doing very manual work to now they're automation engineers, automation testing engineers. So we're finding work for the good talent. You never, one thing in my career is it's hard to find good talent. You will find roles. Maybe they're more skilled, maybe you're going to get more education for some of your staff, but you never want to lose a good IT person because they are truly invaluable. So that's how we answer that part of the question. The first part was, I'm getting old. So
There's no old. What's it going to feel like when technology is making decisions you used to make?
I think it's a great thing. Anything that will take work off my plate is wonderful. There's a lot that I do in a day. If I can get that, Professor, you talked about the mundane work is going to go away. Who likes doing mundane work? Not me. So, some of the skills my neural network over the years has learned how to read trend reports. I won't need to do that anymore. AI is going to be able to react quickly, whether it's managing resources and the trends that are going on there, whether we're using too many, too little, financial trends. It will be able to react immediately. That's great. I can then focus more on strategic work. That is really what interests me, is why I'm doing what I'm doing. So I welcome it. Anytime you get rid of that mundane work, it's a win for me.
Thank you.
I'll start with the first part because that's what you said last. So, I think it's great. Anything that computers can do, better than humans, not just cheaper, but better, and there's a lot of different definitions of better, I think is a great thing. When we first started using computers, this was, what's the advantage of a computer? Well, it can do things faster, it can crunch more data, and those are things that, people aren't good at and can't do it nearly as fast, and then the people do the intellectual part. Well, these are just algorithms and machines that are doing a little bit more. This is not going to be the sort of the Skynet world where you have some super intelligence. If I was taking that survey that they had at NIPS, I'm not sure I would have answered. Definitely not in my lifetime that we're gonna see those types of things. I think where we're moving, and of course this is key to an educational system to be able to adapt to help the industrial parts, is that we need to have our machines sitting next to us and be real partners. It needs to be, we're going to move to a place and a time where our machines supplement our intelligence, augment our intelligence. They're going to start to understand what the needs of the human is. If you have two humans that are partners, they understand each other. They know what each other's weaknesses are and they compensate for it. Computers are going to start to learn these things over a long period of time and really become true partners in being able to augment your intelligence as a human. And from a research point of view, those are the kinds of things that we're moving towards. Again, from a societal point of view, in the jobs, yes, this is going to be disruptive, but it's not the first time. There are going to be key jobs that aren't as necessary as they were. It's not going to be instantaneous. It may seem like it. A lot of these types of things are happening. But there's going to be a process to this. And as an educational institution, we want to make sure that across the board, we are preparing our students to go out into the world and to make the most of these types of situations.
Let's see, so trying to think of the questions in order. I guess the story that comes to mind is it was our second proof of concept where we started trying to employ the technology, and now look at it from an inward point of view. How can this help us in our daily tasks? So we have in our kind of workflow, we have this specific type of material. It's a beryllium copper. It comes in bar stock form for us, and we turn it into these little, very precision parts that are fairly critical. And it's very important that they get heat treated correctly. And we've had problems with field escapes that cost us a lot of money, cost our customers money. And so we really have this very tight quality control that is wrapped around that, how we bring that material and how we inspect it. And it's very labor intensive. We basically have to cut and section. We have Jason here with us from our materials lab. He works in the group that has to spend, once every month or two, the group has to spend 40 hours of work cutting, sectioning, and looking at photos of microstructure of materials. And it's all to make sure that it was done properly at the factory, that it comes in meeting our specs. And it's a lot of work that some very highly trained people do. It's drudgery, right? And so it's by skilled professionals. They're the only ones that know what they're looking for. It's, can we use the technology to figure out how to augment that? How can they do, the machines do the grunt work so we can free those people up to do what we really want them to do, the stuff that's of higher value to us. And so that for us turned into a really good example, all right, because it was a very successful actually application for us, and then it really was fairly profound from a broad implications point of view. And so it does make me think of the slide. The technology has things that it's very good at doing, and it has other things that it's not good at doing. And so it'll have, over the near term, profound impacts. I think that you guys have said that as well. In these areas where it's very well suited, it's a great technology for pattern recognition. If that's your primary job, is gaining skill in pattern recognition, then we really need to think, as that gets automated, what are we going to open your time up to do, and how is retraining needed, or where do we need to go, because this is coming at us. There's other things that it's not good at doing. Those won't go away. We are seeing, in the example I mentioned, with the cameras collecting data out in fields, it's, all right, the data and getting it organized, that's all a skill set. That's a new skill set for us. We're getting that, applying the algorithms, actually getting the data reduced. But the key part is, how do I turn that data into knowledge, into actionable insight? And so it's something that George, as a statistician, calls profound knowledge that guides your actions. And then for us as an opportunity, we are a closed loop company. We in the end think you're going from sensing to, with AI, you're doing your controls work to wrap a loop around it. You're going to want to act on the environment, and that for us turns into the opportunity space. That's what we do. We're out in the environment, but it's really, how do we get these new worlds? How do so it's already affecting us. It's affecting our mindset of what do we need to do? How do we have to do work to do internal training? Back to how do we work with other partners? But there is like a short term and a long term. In the end, it feels like long term it'll have profound impacts in narrow areas, very specific areas. But long term, it's going to affect all of us. It's kind of the long term feel, and so we need to run faster.
That's right, and we're running out of time.
We're running faster.
But I want to just open it up because for a few questions, if I could ask, I'm going to run the microphone to, let's see, right here.
In a related question, how many of you would get into a vehicle that would drive itself on the highway right now? As you're talking about accepting, the new technology.
I would. I would. I know what kind of technology is out there. I probably wouldn't do what some people do and just sit down there and look at your phone the entire time, because there are things in data, but there are statistics out there that show you that if every car on the road today was replaced by a driverless car, you would reduce the fatalities by 95%. And I believe that's probably a low number. Because cars can start looking, and they're going to be communicating with each other. They're going to warn each other about things on the road, things like that. We just don't want to say this is something and point to it and say, okay, it's your fault. We do that all the time with our human partners, right? but you know, we don't want to sometimes let this technology there. And it's, you know, it's part policy, it's part just general acceptance. But I would feel safer in a group of driverless cars than I would, you know, going down some of these with some of the drivers that are texting and things like that.
Next question.
I have a different answer. In the end, at this point where the technology is, I would not go over 30 miles an hour. I would look at it, you know, we come at it from a functional safety point of view, and where is it, where are we in verification, how do we mitigate hazards, and so, you know, and that is how the industry is trying to get their arms around this new technology, is figuring out how do I make it safe, and there's ways, you know, you can either mitigate by making the technology itself inherently safe, or you can control your environment. Those are your two knobs you can turn. And so right now, if you look at the failure rates and you look at the fatalities, it would say, you know, if you want to be at least as safe as you are now, it would stay below 30 miles an hour. You probably wouldn't go into those most crowded environments. You'd look for a little bit more structured environments. Right now, at least that's what I would be looking at with my family. It's like, do not get in that car at 60 miles an hour with it making its own decisions. And so that's just, you know, we all have different kind of viewpoints on it. And so that is something we're trying to figure out, how do we leverage. We do out-of-flight software that lands 400 people hands off. How does this new world, that's why I feel so profound. It's like, this is going to affect us, and it doesn't map cleanly in. How do you verify software in trillions of numbers? It's not, you're not going to do it the way we do it now. And so that is, but the industry as a whole has not figured out how to answer your question yet, which is why you cannot commercially.
Yes, you're right. Planes, there's less environment.
Yeah,
it's easier for planes because there's not a lot of stuff in there.
The structure of your environment and your consequence of failure are kind of like your access of how hard is it. And then there's like a business need. That's where it'll happen first. And then, you know, those higher consequences, we actually look at it, self-driving cars is an awful place to start. And so that's why we're in the agriculture space. We're gonna hurt trees, or, you know, and we can train the farmers, the skilled people to stay out of the way of the machines, and we'll keep them small and slow enough that we're not going to kill anybody. And that's how we'll get started. We'll build hours of experience that'll lead us to the confidence and give us time to figure out the verification means and the explainable artificial intelligence, you know, research that's, you know, that'll help us figure out how to verify these systems.
Next question right here.
Deep learning being such an important aspect of machine learning today, but still research today is, I mean, we're still figuring out what exactly it is. It's still pretty much a black box. So extrapolating this idea, how does industry view such algorithms? Are you all more concerned about the end product, or are you more concerned, I mean, are you also equally concerned about what's actually happening inside the black box?
Yeah, well, very much. That whole story was about we need to understand what's in it, and we don't. And so there is some really good research going on now to figure out, well, how, if I ask you if you're driving the car and you took an action, you have some way to explain how you came to those decisions. If it's completely black box, it's probably not going to play out that way. But on the other hand, we can't understand the trillions of numbers. It's going to be somewhere in between, and it's a great area for active research. But in the end, it's, you know, there are ways to, that was why the whole story was, there's other ways to mitigate. You can use this stuff right now. If you control the environment and put it in someplace safe, you can make money right now while you get, it's really important, get real experience. Even if it is a black box, there's useful things that it can do right now. And so it really comes down to find applications you can use now that make money, that'll pay for the research, that let you get to the next step, and it's like a stair-step kind of an exercise. That's how we look at it.
Medical business looks at it the same way, or?
Yeah, I think like any other technology, over time as we iterate, it gets better and better. And I think at the core of deep learning, the more data and more time you have, the model gets smarter and smarter over time. So I don't think that we're in the earlier stages, but as we progress over the next 1, 2, 10 years, it's going to be a very solid technology. And when I was in Detroit a few weeks ago, they have autonomous cabs, although there's someone who's got to sit behind the wheel, so to speak. But it was pretty cool, and I'm fine with it as long as we're in that 25 miles an hour range, because I think that's what's somewhat perfected at this point. If it was 60, 70, 80 miles an hour, I don't think I'd be taking part in it. But over time, the technology will be extremely mature. But like everything else, we've got to iterate and perfect it along the way.
I'm not interested in trying to learn more about AI as far as studies-wise, but I invest, and I want to start investing in AI. So I want to know where can I find, since there's a lot of information on Google, and where can you find solid information on some of the latest trends and stuff that's happening with AI? Would you have any sources?
Academic one?
Well, I mean, part of the problem is everything you start to read, you have both the utopia and the dystopia piece. You know, if somebody is doing something really, you know, incredible, so Google's providing the tools, and you can see what Amazon is doing, but their business model isn't AI itself, right? They're using it for something else. The fundamental things are going on in these large research labs, again, you have to go out there and experience it yourself. I mean, I think, you know, sort of the Warren Buffett, if you really want to do those kinds of things, I mean, he goes out and he understands the technologies and understands the companies and their business models and things like that. There are a lot of companies out there that are getting investments just because it's AI, and I don't know how you weed those out.
I can tell you how we've been approaching it, which has been, let's see, so first of all, Coursera, MOOCs, excellent. You know, there's those companies have all committed themselves to making this publicly, you know, available information. So, but it's almost like there's too much information to sift through. And so the other half of it is that traditionally we're an engineering company. We hang out in, you know, mechanical and electronic and software engineering, system engineering parts of universities. We're now starting to hang out in the computer science department. And so yeah, we know Kartik. We've been working with him. We co-proposed on something over the Christmas holiday. You know, Niels Knapp, you know, we're hanging out with people that have actually, other folks that are actually trying to use this in anger and are having to try and sift through that sea of information to find where those nuggets are. But then the other part of it is actually, you know, getting your hands dirty, doing it for yourself. Because in the end, it's almost, you come down to it, it's not that hard to actually make use of these and try these tools. I mean, what inspired us was a story we keep telling internally about a Japanese pickle farmer. And so we're doing a lot of work in metal additive manufacturing, where we're trying to master processes that have 150 inputs. And so that's why George works a lot on additive manufacturing. We have to do a lot of statistics to sort through what to do. And it's like, well, can't machine learning and pattern recognition, there's got to be a use for this to help us sift through all this sea of data that we're going through. And so we started doing a lot of looking online, and we read this story about this Japanese pickle farmer who inherits, he works at an automotive company in Japan. He inherits the family business, which is growing cucumbers. And it turns out that like perfectly formed cucumbers are worth way more money than malformed cucumbers, and his mother is the one that sorts them into these 8 buckets of different categories. And he's trying to learn from his mother, like, how do you do this, Mom? And he realizes it's really hard. He's trying to figure out how his mother knows how to sort them into these 8 categories. And then he thinks, hey, you know, with $3,000 laptop, some TensorFlow open source library, and you know, a little bit of motion control, he built a cucumber sorter. So we set that thing around internally and said, hey, if the cucumber farmer can do it, we can do it. And that's really what it turned into, is that, you know, we got some really good engineers. They put some time into it. They sift through the information, do a little bit of working with others, but it's really, so it was those 2 things. There is a tremendous amount of extremely high quality stuff out there, and then sorting through it, it's like, so starting with the university partners that have a good idea, because a lot of their research work, that's what they're doing every day. And from there, it's like, you know, there might be 10 open source libraries. You're trying to do this one's the best at it. Don't, you know, stop wasting, don't try the other 9, or at least, you know, try these 2 instead of all 10. So that helps a lot to speed things up.
Okay, one last question. Okay, what do you think? Right here. And we're gonna wrap it up, and you guys can get home with your families.
Thank you, by the way. I really appreciate this. Let me just give you a little bit of context and then jump right into my question. There's a company called Kloop that I think just got purchased. They're in the marketing arena, so they help marketing companies, any companies that they're trying to market on social media. Basically, they use AI to understand sarcasm and are able to convey the right marketing message based on that sarcasm, right? So when somebody, you know, tweets, I just got a new iPhone and it's sick, it knows that it's really not sick, right? So, interesting enough, you know, we talk about how AI is sort of replacing some of those mundane tasks. That's an example that a creative director at a marketing agency may not consider that as mundane, that's creativity. And that's sort of where my question comes in. And there are certain patterns in terms of what we aesthetically like, in terms of our own perception of what we enjoy around the world. And the question that I'm kind of just throwing out there to get your thoughts is, logically we're talking about AI replacing mundane tasks, but at what point is this technology going to progress to a point of actually replacing human creativity, or maybe even doing human creativity better? And I guess the question is this something that you guys have already noticed that's potentially coming down the pipe quicker, or is this one of those things like, yeah, maybe 150 years from now? Just want to get your thoughts on it, because once again, there's a lot of conversation about AI being mundane, but I'm also noticing AI sort of jumping into that creative world that people would never think that AI would be.
We've been watching machines applied to writing music, right, or doing paintings, those creative activities that normally you think of as restricted to human. We are not far enough up the learning curve to really project timelines or know what the implications are. And so really it's focus on provide value feels like the key kind of mindset that we're taking to it, because it's like back to that story of like the scarce resource are going to be the people that can pull out of the sea of data, and then out of that patterns that we're recognizing, what do we do with it? What's the actionable insight? And then how are you finding new ways of providing value to do that? So one way or another, it is, and so don't just think that, it's creativity is somehow off limits, only humans can do it. It's like almost, I have no idea where this will stop. And so then therefore focus on how do I do something useful for ourselves, for society, worry about the impacts, because there is, this is going to happen, it feels like, very, very quickly. As you map out industrial revolutions and how long they take to evolve, it feels like we've laid all this infrastructure to let it happen very quickly. So you've got to really kind of step back and perceive broadly, because it's not clear to us where the boundaries are. And so it's just an experiment, but try and push yourself in to do something useful. And then don't go into it deciding there's a boundary. It's like that feels like the wrong thing to do right now.
So I think you're talking about completely automating these types of things. But I think even now there are ways for these creative artists and things to do things, tools out there that give suggestions that they might be able to do things faster, try things out. Even the things that are in Photoshop now for intelligent removing of things in pictures, digital manipulation, GANs that can generate and replace faces in movies where an actor has died or something like that. There are these pieces there that the tools there that enhance the human's creativity and their ability to do things faster. I think that's one place that we're already seeing it.
Yeah, and I think just like we said, over time, it's definitely going to be reality. It progresses pretty quickly, and I think many of us use AWS today. We now have access to resources we didn't have before because we were cost constrained. To bring in very large compute power was cost prohibitive, so you weren't able to make a lot of the gains that you can today with elastic resources that you can get through AWS. You can get many processors, a lot of memory, very cheap. Spin some stuff up, and I think we're just iterating very quickly through that. I don't know if this falls into a creative question, but I have a colleague that we communicate mostly through LinkedIn Messenger, which probably isn't the best way to communicate, but for some reason we do. We found that we can have almost a whole conversation without either of us typing anything. The AI has gotten so tuned to the way we communicate with each other, it's relays it. Okay, that's what I would say, and it's creepy, but it's where we are. I think we all have to get used to that.
Well, thank you, panelists, and I want to thank again tonight for everyone for attending. This is definitely a Friday night. It's a great testament on how exciting AI is going to become, and our world's going to change. I want to thank everyone from UB, from again Chungming and Shelley, and BNMC, who was our partner tonight, and Jen, who checked us in, everyone who helped us out, and I think it was just a great show and a testament how exciting this is. And We heard about pickles, the pickle optimization to Tesla. Tesla's leaning down, saying what he was a leader, and again, our world. We really, and our keynote speaker, Professor Srihari. It's just great to have leaders in this space. So we thank you for your time tonight, and thank everyone for coming. I hope that the event was exciting and rewarding, and the food was okay. That was okay. Well, thank you again, and I'm going to give a quick note to.
Well, I also want to thank Sam for really helping, organizing this BMMC, and the volunteers, Shelley, and all the student volunteers from UB, and some of my colleagues who are here. I also want to thank our provost, Chip, for being here. And we wanted to finish this before 8, so some of you can still grab a beer and have time, networking with our distinguished keynote speakers and panelists. So thank everyone. Thank you. So you guys can go out and enjoy beers, and we also have a chance to talk to the speakers and panelists.